Hi, here we are trying to learn a bit more on Python Flask. Now, we learned in the last two episodes of learning Python Flask how to create APIs. Now, here we are in a situation where we know how to create APIs, and here is a sample API code, which is a get API, a hello world API. So we know how to create the API. We also know how to test it by deploying it locally. But when it comes to deploying it in production, we have to deploy using a more powerful web server. As we know, Flask is a micro web framework. It's a micro web framework. This helps us to create APIs and much more. But as I have been talking about, we need a more powerful web server which can host these APIs. So that is where today I would like to introduce Tornado, which is also a web framework in Python, but that supports us with a more powerful HTTP server. So which can be leveraged by Flask to host the application. So here is the code. As you can see, this uses the app that is built in Flask and hosts it in HTTP server as provided by Tornado. Now, one of the reasons why we use Tornado is that it accepts a large number of connections, which is more than what Flask can accept. So here I just would like to run the application and show that it works fine. So here we start the application. This is started the application now. Okay, so in case if you have not watched the two episodes of us, before you start watching this, I would recommend you to watch the videos in the in our channel, which you can also see. We will post the link in the yeah, it'll be posted by us in the description. Well, so here we go. I would like to test the application API that we built. Here localhost 5000 should say hello world Emmanuel. So this means this API is working. Now, as I've been talking about API accepting large connections, I would like to introduce you to a load testing tool for APIs, especially which was also using Python, which is Locust. Here we go. The site is locust.io. It provides us with an open source load testing tool which can help us to very easily test the APIs. We can load it with multiple levels of user connections. Rather, we can make the tool spawn up a lot of user connections and load test the APIs. So it requires us to create a configuration file locust file.py. So it also gives the example. So I just created a sample file which is locust file.py, where I'm just calling my API, which is just a slash. You may wonder why slash will point to this particular application. We will give the base URL in the uh, locust application when we test it. So here we go. I'll create one more terminal connection here. Then say pi minus f locust file dot py. Okay, so here we get an error. It tells, let me quickly check that. Let me quickly check. So this is locust minus f, not pi minus f. So let me now do that again. Locust minus f, locust file dot pi. So here it should ideally start the locust application. Yeah, so it started. So now we will have, as can be seen in this, in localhost 8089, this application is running. So we'll go here, say local host :8089. This will throw up this application locust.io. Now here we have number of users, so I would say 100 users. Spawn rate at any point in time 5 users at a second. So the host is localhost 5000. Let's start swarming. So you see here for every second it will spawn 5 users. You can see that right now 35 users it is showing, 45 users. So we will see the chart that will also show us how many requests are getting spawned at any point in time. So requests per second 14.6 at an average. There are 100 users. Now we see here, yeah, it's already 100 users. So time taken, you'll see that it's varying. The point here is response time also in milliseconds. Number of users steadily from 0 it reached 100. It's stabilizing in 100. Response time is much less. Fine. So we can see there are failures. Apparently no failure. There are any exception, no exception. Okay, we can download the data if we want. So this is what it is. Number of requests. Well, so here we have 100 users.